Hey guys, so in this video we will try to solve the longest common subsequence problem. In the previous video we already solved the longest common subsequence problem with the help of memoization, and in this video we will try to solve this problem with the help of tabulation. Alright, so for those who don't really know what the problem is, in the problem you are given two different strings and you have to find the length of the longest common subsequence of the two given strings. Alright, so for example, in this case, let's say a equals to abcde and b equals to ace. So in this case, the longest common subsequence of these two strings will be ace, and thus since its length is equals to 3, the answer will be equals to 3. Alright, in the same way, if we have a look at the second test case, the two strings are xyza and yyma, and the longest common subsequence of these two strings over here is equals to ya. So since its length is equals to 2, answer will be equals to 2. And for the third test case, since they have no character in common at all, the answer will be equals to 0 because there is no common subsequence in the two strings. So let's see how we can solve this problem over here with the help of tabulation. So we already have a function over here, int LCS, and we have to complete it. In the function we are given two parameters, that is string a and b, and we have to actually find the value of longest common subsequence of these two strings. So in the previous video, we had already laid down two properties of this dynamic programming problem, that is the definition of dp of I comma j. So in this case, we'll solve this problem with the help of two-dimensional dynamic programming. So dp of I comma j in this case means the length of the longest common subsequence of a of the substring a of I to n minus 1, that is the substring starting from index I of the first string and ending at the end of the string. So that is a of I to n minus 1 and b of j to m minus 1, and nm and nm are the length of the strings a comma b respectively over here. Alright, so this is the definition of dp of I comma j. If you are having trouble understanding this, I had uploaded a dedicated video on the theory of the longest common subsequence, so you might want to watch that if you are having trouble understanding that. So the recurrence relation had two different cases. So the first case was if a of I equals to b of j. In this case, dp of I comma j will be equals to 1 plus dp of I plus 1 comma j plus 1. Alright, so this becomes our recurrence relation in case of a of I equals to b of j. Otherwise, our recurrence relation is something like dp of I comma j equals to max of dp of I comma j plus 1 comma dp of I plus 1 comma j. Alright, so this becomes our recurrence relation in these two cases over here. So now the third sub problem is, so these two sub problems we had already dealt with in the previous section, and we actually dropped the third sub problem of a dp over there because we have already discussed it several times that there is no importance of third sub problem in case of memoization, but in case of tabulation there is an importance of third sub problem, and the third sub problem is laying down the topological order of the states, that is the order in which we will solve the states in. Alright, so for that we should have a look at the recurrence relation. Alright, so in this case, if you want to understand the topological order, the theory behind the topological order in which we will solve the states, you can again have a look at the video where we had uploaded the theory of the longest common subsequence problem. Here I will just lay down the topological order in which we have to solve the states in. So the topological order will be something like this: n comma m, so these are the states over here, then n comma m minus 1, then n comma m minus 2, and this will go on up to n comma 0. Alright, now the next element over here will be n minus 1 comma m, then n minus 1 comma m minus 1, and this will go on up to n minus 1 comma 0, and then this will go on up to 0 comma m, 0 comma m minus 1, 0 comma m minus 2, and so on, and 0 comma 0. Alright, so this will be our topological order. First we will solve the nth row, then we will solve the n minus first row, and then up to we will solve the last row over here. Alright, so let's just get started with the code part. Alright, so these are the three sub problems that we needed, and this is the third sub problem over here. So now we can code the tabulation thing up. Alright, so let's get started with that. Now there are two base cases in this case. So the base cases are something like this: if I is equals to n, where n is the size of the first substring, or j is equals to m, in that case answer will be equals to 0. Why is that? Because I equals to, if I is equals to n, so if you have a look at the definition, a of n comma a of n colon n minus 1, if you have a look at this, a of n colon n minus 1, it will represent an empty string over here. All right, so any the common subsequence of an empty string with the longest common subsequence of an empty string with any other string will be equals to 0. So that's why if I equals to n or j equals to m, the answer will be equals to the dp of I comma j, the value of dp of I comma j for these two cases will be equals to 0. So that means we should initialize the nth row with value 0 and then move and then consecutively solve the other rows with the help of it. All right, so let's just get started with it. Initially we will take O of n into m space to solve the problem, and later towards the end we will see how we can optimize the space. All right, so let's just before we define the state over here, let's just initialize two variables over here. For simplicity, n is equals to a dot size, that is size of the first string, and m is equals to b dot size, that is size of the second string over here. All right, so now just let's define the states of the array, that is n plus 1 comma m plus 1 over here. All right, so now that we have defined the states of our array, let's just initialize the nth row with value 0 for int I equals to, let's just iterate with variable j, it will look better. So for int j equals to 0, j less than equals to m, j plus plus dp of n comma j equals to 0. So this is what we wanted over here. Now we will solve the states in this order over here. So we'll iterate over the rows in decreasing order. So for int I equals to n minus 1, I greater than equals to 0, I minus minus, so we'll iterate over the rows in this order over here. And the first thing that we'll do is we'll initialize dp of I comma m equals to 0. So this is again the base case over here that is derived from this line number 35 over here that we wrote over here. All right, now we will iterate over all the indices j in the decreasing order array again. So it will be j equals to m minus 1, j greater than equals to 0, j minus minus, and then we had two cases in the recurrence relation, if you notice, that is if s of I equals to in this case it's a over here, not s. So if a of I equals to b of j, in that case what we need to do is dp of I comma j equals to 1 plus dp of I plus 1 comma j plus 1. Otherwise else dp of I comma j equals to max of dp of I plus 1 comma j comma dp of I comma j plus 1 over here. So this becomes our recurrence relation over here, and that's all for the loop. And now the final answer is dp of 0 comma 0. So let's just return that. Let's return dp of 0 comma 0 over here. All right, so that solves pretty much everything. So let's just try to compile it and see if this works or not over here. All right, so if you notice, we got all the answers correctly. All right, so all the answers that we got over here are correct. So I hope that this was crystal clear. Now if you have a look at the time complexity and space complexity for this over here, so the time complexity is O of n star m, where n is the length of the first string and m is the length of the second string, and the space complexity is O of n star m again.